All right, let's get right into it. Today, we're stepping into the ring for a real heavyweight bout in the world of big data. In one corner, you've got the reliable original, Hadoop, and in the other, the lightning-fast challenger, Spark. We're going to break it all down and figure out which one is the right champion for your data needs.
So if you're dealing with data on a massive scale, and I mean really massive, you've almost certainly heard of these two. They're absolute titans in the industry. But here's the thing. They tackle the problem in completely different ways. So let's get into the story behind these incredible frameworks.
First up, we've got Hadoop. You got to think of this one as the original trailblazer. It's the foundational tech that showed up way back in 2006 and basically opened the doors for everyone, not just a couple of tech giants, to process just enormous amounts of data. So, the whole point of Hadoop was to solve a simple but massive problem. What on earth do you do when your data is just too big to fit on one computer? Well, the answer was to spread it out, to distribute it across a whole bunch of regular, off-the-shelf computers. And that made big data processing affordable for pretty much the first time.
So how does this whole thing actually work? Well, it's a team effort, really. You have HDFS, which is kind of like the librarian, cleverly storing pieces of your data all over the system. Then you have MapReduce, which is like a whole team of researchers all working at the same time on different parts of the data. And finally, Yarn is the project manager, making sure everybody has what they need to get the job done.
This right here, this is Hadoop's core philosophy. It's built for absolute reliability and for handling just huge volumes of information. Kind of like a massive library archive. It reads data from the disk, it processes it, and then it writes the result right back to the disk. It's super methodical, super thorough. It's all about getting the job done right, not necessarily getting it done in a flash.
Okay, so now let's meet the challenger, Spark. Spark came along a bit later, around 2010, and it was created for one big reason, to fix Hadoop's biggest weakness, its speed. It's the nimble, agile successor built for a whole new era of data analytics.
Now, you see that phrase right there? In-memory computation? That is the key. That was Spark's game-changing idea. See, instead of constantly reading and writing to slow hard drives like Hadoop does, Spark just pulls the data into the computer's super-fast RAM and does all its work right there.
And Spark is so much more than just a speed demon. It's a whole toolkit, all rolled into one. Whether you're running SQL queries, you're training machine learning models, or analyzing live data streams as they happen, you can do all of it inside one single framework. And for developers, that unification is a massive, massive advantage. So if Hadoop is that giant library archive, Spark is more like having all your research materials spread out on a giant workbench right in front of you. Everything is right there, in memory, ready for you to access and analyze pretty much instantly. This is what makes it so incredibly powerful for tasks that need to go over the same data again and again, like machine learning.
Okay, we've met the contenders. Now it's time for the head-to-head showdown. How do these two frameworks really stack up against each other when we look at the things that matter most?
You know, at the end of the day, it all comes down to this one fundamental difference. Hadoop is disk-based. It's constantly reading and writing, which is reliable for sure, but it's also slow. Spark, on the other hand, is memory-based, which is just unbelievably fast. This single choice in their design is the reason for almost all their other differences.
And the performance gap? I mean, it is staggering. For the right kind of job, especially those iterative machine learning tasks we talked about, Spark can be up to 100 times faster than Hadoop. Let that sink in for a second. That's not a small improvement. That is a revolutionary leap in speed.
This table really breaks it all down beautifully. You've got Hadoop, which is slower but needs less memory, making it a bit easier on the wallet for hardware. Then you have Spark, the speed demon, but man, it is thirsty for RAM. Development is also often way faster on Spark because of its modern APIs and languages like Python, while Hadoop can feel a little more complex. And here's a big one. Hadoop comes with its own storage, HDFS, while Spark has to connect to something else.
So, with all that information on the table, how do you actually pick a winner for your project? Well, the answer, as you can probably guess, depends entirely on what you're trying to do.
Yeah, it's not about which one is better in some abstract way. It's kind of the wrong question to ask. It's all about which one is the right tool for your specific job. So let's get practical.
Okay, so you should go with Hadoop when cost is a huge driver and you're dealing with truly massive data sets that need super reliable storage.
It's absolutely perfect for those huge, overnight batch jobs, think ETL processes, where you care more about just getting through a mountain of data than you do about getting an instant answer.
On the other hand, you absolutely 100% want to choose Spark when speed is the name of the game. If you're doing machine learning, or analyzing real-time data from sensors, or letting your analysts explore data interactively, Spark's performance isn't just a nice-to-have, it's a necessity. But hold on, here's the big twist in our story. This isn't always a competition. In the modern data world, the most powerful strategy often isn't choosing one over the other, it's using them together.
And this quote just captures it perfectly. The best of both worlds approach is incredibly common. You use Hadoop's HDFS for what it does best: cheap, reliable, massive scale storage. And then you run Spark on top of that very same data for what it does best: lightning-fast processing and analytics.
So you see, it was never really a simple choice between just speed and scale. These amazing frameworks have evolved to work together so you can have both. The real question, the one that really matters, is with these incredible tools at your disposal, what amazing things are you going to build with your data?